All right, so next month we'll have a presentation on React and React Native with the .NET Core backend. So come back for that one, and then the following month on caching with .NET Core. So tonight we've got Docker with .NET Core with Clayton Hunt.
All right, first things first. Can everybody read all of that? I'd rather not go full screen because then I have to pull it out of full screen but there's not a whole lot of text that's going to be up here. So can everybody read the small text?
Yep, looks great.
Everybody? All right. So then, how many people are DevOps? Because John said there was a few DevOps. Anybody see? DevOps. Okay, not that many. Everybody else is devs? Yep. All right. How many people have any experience with Docker? Awesome. Then you won't know if I'm lying. Okay. As he said, I am Clayton Hunt, co-founder of this meetup, even though John's the face and I just sit behind the camera most of the time. I also blog on Six Figure Dev, which is mine and John's blog, and then Programming from Scratch, which is really, really entry-level stuff, like how to do math in JavaScript. So really low level. My Twitter handle is @ClaytonHunt_104, and then for fun, I burn myself doing backyard foundry work, blacksmithing, and then I run into trees on a mountain bike on the weekends. All right, so what is Docker? Everybody's familiar with virtual machines, right? Speak up.
Yes.
All right, good. There we go. Okay. So a Docker is like a virtual machine, but only the part that's going to run your app. All of the rest of the stuff is generally hosted in a VM, especially on Windows, but not something that you have to deal with. All you have to deal with is the file system and the particular installed components that you need for your application. Is anybody familiar with Thin Client from like way back in the day, done by Citrix? It's actually a lot like that. It's just the bits that you need to run your application. But no graphical applications. You can only do command prompt based applications. Wow, that one is small and blurry. Okay, so if you wanted to get Docker, it's really, really simple. Just Google for Docker, and then you'll probably see a download link in the Google search. But if you don't, you go to their website, and on the front page, they have a get started with Docker, and it'll step you through getting started. The only important thing that you have to do after you have Docker set up is make sure to go, let me see if I can bring it up. There is a setting that you have to have. So over here, if you can't read it, it says shared drives. You have to go to shared drives and make sure that you share the drive that you're going to be using any files from for Docker. Otherwise, you can import files, but you can't actually edit the files on your machine. So any changes you make are locked in the Docker container, and then they get lost if you ever delete it or something happens. There we go. All right, so there's a few pre-built options for Docker that I don't use. Did everybody watch, was it Connect? Can't remember the name of the conference, but in like November there was a conference and Donovan got up on stage and in like 5 minutes he right-clicked his way to success with Docker. That's in Visual Studio 2017. In Visual Studio Code you can download a Docker plugin and you can essentially right-click install Docker. There are Yeoman generators. Anybody familiar with Yeoman? No? Okay. So Yeoman is an application written in Node in JavaScript, and it allows you to generate, you can generate a whole .NET app, you can generate MVC controllers, or in this case you can generate the stuff you need to run Docker for your application. And then there's, I don't know, hundreds and hundreds of starter kits for everything under the sun now. Angular's got starter kits, Docker has starter kits. I don't use any of those, and I don't use them because I tried right-clicking my way to success with Visual Studio 2017, and after doing a project conversion on the application that I wanted to Dockerize, it didn't work. I tried the Docker plugin for Visual Studio Code. It didn't even run. I tried the Yeoman generators. It didn't run. I tried about 5 of the starter kits. They didn't work. Doesn't mean they won't work today, but when I tried them, none of it worked. Plus, if you are working with a DevOps professional like Hudzy back there, yeah, just single him out right there, that guy. you will need to be able to understand your Docker configuration so that when they ask you to change something, you can actually go and change it. And with all of those solutions, you open up the files that control Docker, and it's gibberish. There's 15 lines of stuff that you're not going to understand unless you're really, really deep in Linux. And if you're here doing .NET, you're probably not really, really deep in Linux. So that's the reason why I don't use that. For this demonstration, the whole walkthrough, I'm going to completely create the application inside Docker. I don't even have the right version of .NET Core installed on this machine. I've got 1.0 and I need 1.1. So we're going to get started. I have a repository, which I meant to add a slide. I'll enlarge it and make it large at the end of the talk so everybody can go see it. But in that, I've broken everything down into a few branches, which you can't read, but there's an interactive session, which is where we're going to start, and then we'll work through the rest of them. So in Visual Studio Code, the files on the side are unimportant. I will let you know the ones that actually matter, which are the Docker file and the run.bat. So this is an example of a Docker file. The Docker file is what controls how your application gets configured so that it can run. From is so that you can specify your starting point. There are hundreds of thousands of images already at a site called Docker Hub, which is a repository just like NuGet or NPM, or if you're on Linux, any of the repositories there. Except for it has Docker images on it. And the Docker image is just the files that you need to actually run. When I say Docker container, that's the actual running application. The image that we're going to start with, can everybody read this, or do I need to make it bigger? People in the back, you guys good? Bigger. All right. All right, I got an iffy. We're going bigger. Let's see how large I can make the font. All right, we're at 24. Let's go stupid and do 28. Better? Larger? That's good? Okay. So in this case, the image that I'm going to be pulling from Docker Hub is a Microsoft image named ASP.NET Core-build. There's two versions of this image. One of them has -build and the other one doesn't. If you're going to be doing development, you have to have -build. The version of that image that I'm getting is 1.1 project JSON. So .NET Core is moving to MS Build, but when I started putting together this talk, the project JSON was still the way to go. So that's what I've gone with. Unfortunately, and this is a real problem for DevOps when you try to integrate Docker into your whole system, these versions aren't real versions, they're just tags. So 1.1 project JSON has actually been updated like 20 times. So the files have changed. You haven't developed on your application in over a month, but the team that's maintaining this image updates the image, and in production, all of a sudden your app doesn't work. And it doesn't work because they upgraded to an incompatible version of Node, or they upgraded to a patch version of .NET 1.1, and now your code's broken, and you didn't even change anything. So the way to combat that is, the one thing that does not change and that is specific to a particular image is the SHA-256 hash. So you can append that onto your Docker configuration. You just say @SHA-256 : and then the hash. The only way you can get the hash is when you actually pull down the image the first time. So if you're doing this for your work, you'll have to pull down the image, scroll up in your command prompt, copy that hash, and then stick it into the Docker file like I've done here. Once we're in the container, the running container, which will be based on the ASP.NET Core build image, we're in Linux now. So all the commands have to be Linux-based commands. In this case, I'm going to run the shell, just the bash shell, and we'll stay there. The way that we tell Docker what to do is with a command line interface that they created. So in this case, I'm going to build my image, based on the file that is .source/docker file. That's from my current location. So the file I'm in is run bat, which is in my base directory, and then all my source files are going to be in the source directory. So I have to cruise to that source directory so that I can actually reference that Docker file. I'm going to tag it with interactive Docker because my intent is to create a prompt that I can then do things with. The dot right here is just saying that when I execute I'm starting from my current directory. So after I've built the image, then I'm going to run the image. So it's docker run. --rm says that when I exit the image, it deletes it. And I've done this because the images will just pile up. It's a train wreck if you let them pile up. So I always remove them when I'm done. I'm going to give it a name, and the name is interactive Docker. Then -it says I want to be in interactive mode using TTY. So I get the console feedback from the system that's running, and I can type in commands to send to that system. -v in this case stands for volume. So I'm going to mount a virtual hard drive space on that Docker machine. This is a batch script. So the %cd% says my current working directory. And then a / is for Windows. If you were in Linux doing the same thing, you'd have completely different commands to find your local directory. It's really annoying. Then the colon says, so here's cd/source is my directory that I want to use. :/app is the directory on the virtual Docker machine that I'm going to be putting files in. The -t is a tag. So just like the 1.1-project.json that we saw in the Docker file, I'm going to tag my image, my container, with interactive Docker. So I've named it interactive Docker, and I'm also tagging it interactive Docker. So when we run that, I'm in PowerShell, so I have to do that, which is stupid. All right, everybody can read that, right? All right, so when I run it, almost nothing happens. It double-checked the image. You can see here is the SHA saying that it's confirmed that that's the, you probably can't see my cursor. Right here, it's just confirming that that's the image that I have locally. I pulled it down ahead of time because it takes a few minutes to pull down a new image that you don't already have. And then it's going to run my entry point command, which is to execute the bash shell. And then it's going to give me a security warning because I'm on Windows. And then it's going to run the two commands, and we end up with this hash, which is the Linux command prompt for bash. From here, if I ls, you can see I'm not even on my machine anymore. I'm on some Linux machine. There's for Windows, they actually have a virtual machine somewhere that you can use. Depending on your configuration, it's either a Hyper-V machine or a what is it, Oracle's virtual machine application. Yes.
Where did you configure where to pull the image from?
That was in the Docker file. So I'm saying to go and from this Microsoft/ASP.NET Core -build.
But you mentioned it came from Docker Hub.
Yes. Sorry, say again?
Where is that configured to pull it from Docker Hub?
That is the default automatic configuration.
Okay.
So as a default, it will either pull from Docker Hub or it will pull from your local images that you already have available, which as soon as I exit this prompt, I'll show you how to see the local images. Oh no, that was, nope. 1 second, there we go. Let me clear, okay. So now we're in this Linux machine. We want to create our .NET application, so we cd to app. So now we are in app, and the only thing in app is my Docker file. I'm going to make a directory using docker.web. Oh, can't tab. Using Docker. So you guys probably can't see it, but did anybody notice the using docker.web directory show up on the side? So I'm actually affecting my local file system by operating inside the Docker container. But I can run commands that I can't actually run properly on my local machine. So transition into that, and I think this syntax is changing also, but so I'm going to create a new .NET application of type web, and then it just spits out. And then if you have the proper version of .NET installed, these little prompts that showed up at the top, they're just telling me that Visual Studio can restore the all the DLL requirements of my application for me. I don't want to though, because I'm actually running in my container. So I can restore those packages and they stay in my container. They don't end up polluting my file system. But now we've got that, so we can actually say .NET restore, and then it's going to go and download all the stuff. Hopefully it doesn't take too long. While we're waiting on that, does anybody have any questions up till now? Yes.
2 questions. How big is that ASP.NET Core Docker image that you're pulling down, and what flavor of Linux is it running under the hood?
Okay, so it is running a version of Debian, and currently, unfortunately, it's about 1.5 gigs. Yeah, they're working on a much smaller version. Has anybody heard of Aspen Linux? You have? Okay, Aspen's like 5 megs, right? You add the .NET Core files, that's maybe a couple hundred megs. So you can end up, and they're working on it right now. They do have code that they're working on, but shortly you'll be able to do the same demo that I'm doing, but only spend 300 megs instead of over a gig. So everything will run a lot faster. All right, any other questions before we continue on? No? All right. So now I've restored, and then anybody who's been working in Core should be familiar with that one. So now my application's going to run. I've got TTY, so I get all the syntax highlighting and coloring and all that. The only problem is now my application's running, but like I was saying earlier, it's not running locally. So it said port 80. So if I try to go to port 80, nothing happens. I can't actually access my running location right now. But that's why this first step is just creating the application. It is a local system, and you guys aren't going to be able to see the individual files, but you can see like I've got the whole directory structure local. So this is where this particular setup now is useless. I can't progress any further. So we have to make some changes. Oh, and to exit out of the Docker container, if you're in an interactive session, is the same as exiting a command prompt. You just type exit and hit enter, and then it'll drop you back to your file system. All right, so now that we've created the app, we did not cover copy, working directory, or run. So copy does exactly what it sounds like. You say, I want to copy something from my local system to my container file system. Working directory is just the starting point. So if you run the interactive session, and we'd said the working directory was /app, then when that interactive session started, we would have already been in /app instead of me having to cd into that directory. Run is your opportunity to actually just run a command. So I can run any command that I want to. In Docker, when you run a command, it gets baked into your image and into your container. So if I run restore and I don't change any of the packages that I'm referencing, technically that run restore wouldn't have to happen again, because Docker hashes all of the layers, is what it calls them. So every run is a new layer within the file system that Docker caches and has access to. With .NET Restore, it doesn't work quite right because it doesn't know that it's going to be the same. But with some commands, it knows that no changes happened, and so it won't actually run those commands. The next time you access it, it will skip over that command because it knows that the hash is the same, which is really fantastic. If you have a repetitive task that's not dynamic, then it will just completely skip all of those the next time you need to run, and you'll have an instant boot time instead of waiting for that process. And then entry point is kind of what it sounds like. It's what's going to happen when the Docker container fires up. It's your starting program that you want to run. All right, so now we're going to move on to continuous development. right? We want to be able to develop without having to restart the system, without having to go through a painful process of shutting down this image, starting back up this image, because it does take a little bit of time. What's after this? Oh, sneak peek. Okay. So, like I said, there's images that I have, or branches that I have preset that I don't. Awesome. Okay. Get branch. Get check out. The next one is .NET development. It just said I didn't have any changes. All right, that should put us back to start. There we go. All right, so this branch is pretty much where we just left off. In fact, I think it is. Let me check one thing. So if we want to be able to run our application continuously while we develop, then we'll need to add, and this might be missing from here. If it is, then I'll show you. Yeah, it is. Okay, good. So there are changes to the run file. So after we do the interactive session and we've got our files created, we need to make some changes. In this case, I moved the Docker file into the folder where our web application is, because now that Docker file is specifically for the web application. And I don't believe, no, it did change. Ever so slightly. It's the same SHA hash, but we've added copy. So now we're going to copy everything that's in the root of where the Docker file is to our /app in our container. We're setting the working directory to app, so our application will automatically be dropped into there. We're running .NET Restore, and then we are going to run .NET Run automatically when the container launches. In our run, we're going to change our directory to be the same location as the Docker file. Then we're going to build our Docker image from that Docker file, and we're going to tag it .NET Development. That's very similar to what we were doing earlier. Then we're going to run the image, same as before. We're going to remove it when we're done with it. We're going to name it .NET-Development. We're going to make it an interactive terminal. This time we're doing something a little different though. -P is setting port 3000 on our local machine to be mapped to port 80 on our Docker container. So before, when we were running the application and it was running on port 80 and we couldn't access it, now we should be able to access it with port 3000. And that you could make whatever port you want. It does not matter. You could even do 80 to 80. I generally don't do that because you might have 6 different applications going and you can give them each a different port. And then we're going to tag it with .NET Development. So the only change really is the port number. And then we're going to finish by changing directory back to where we started. No, we're not. Now we are. All right, so this is still not continuous development. This is just the next step. This is why we want to move towards continuous development. And now's probably the time to tell you that without the 30 lines of gibberish that I was talking about earlier that all those solutions try to implement, we can't have debugging. So say goodbye to debugging, unless you want to do the 30 lines of gibberish that you probably won't understand. You might, but I don't. So, but I do test-driven development, so I don't care about debugging. I just write a test. All right, so nope, other way. No, I don't know. It's one of those. Okay, good, there we go. So now we're gonna run, and our application should launch any second. Again, because it's a dynamic thing, we have to run restore packages every time, which kind of stinks, especially in the pre-continuous development system. Any questions while we're waiting? Probably gonna have to do this a few times. Just have questions ready.
Is there anything with like DNS binding or things like that you could set up on the ports?
I haven't done anything with DNS, but I'm sure you could. I mean, anything you can do in a Linux environment, you can do with Docker. So if you could set up a firewall and have Nginx running and do port forwarding and load balancing and all kinds of craziness if you really wanted to. Later we'll get into a way where you can run several different containers and have them interact with each other. In fact, we will start doing that with the next step. All right, so now we're running on port 80, which we mapped to port 3000. So if we come back over here to, that's 5,000, 3,000, and we run it, now we should get a response. Yay! All right, it's the base application that everybody knows and loves, which is all we're sticking with because this isn't about developing in .NET. It's just about getting the application running and deployed. So nothing special, just the base application. Unfortunately, this is why we want to move to continuous development. If we go and make a change, our boss said, hey, the home page needs to say something special. Where's an easy place to recognize? Right there. So because we're here, we want to say, hello, St. Pete, right? So we save it. This might actually work even though I don't want it to, but we'll see. I don't think it will. Yeah, so even though we've made that change, and you know from like, if you're working in Visual Studio and all you change is an HTML file, you would see the update, but because of the way we're running, you don't see that update. This is amplified when you do actual code changes because we actually have to, no matter what change we make currently, we have to stop the container, which Control C if you want to, just like if you were running it local, Control C to stop and it'll exit out automatically because the only command you told it to do was .NET run in this case. Now that we've stopped it, we can just run it again. It'll rebuild the image, restore the packages, and then when it runs, we should be able to refresh our page that we were on and see that it says hello St. Pete. As soon as it finishes. Questions?
So is the solution to create a symbolic link back to the host directory?
Right now, all we're doing is copying the files.
Right, but the next step.
The next step is we're going to use, this step is not using volumes, which we used when we created it. And the next step, we're going to turn volumes back on. And then we're going to add, is anybody familiar with a watch? Not like a watch, but like a file watch.
Yeah.
Okay, so there's .NET Watch, which allows you to rebuild your application automatically when any part of your application changes. You change a HTML file, it rebuilds. You change a code file, it rebuilds. And as long as we don't change our packages, we can rebuild all day and not have to go back through restoring the package, not have to go back through restarting the application. It handles all that for us. And then we can magically write a little code, go refresh the page, see how it works. Made me just give away the whole magic. It's all right. Okay, so we're back to running again, and we should be able to refresh. It's going to take a little bit because we now have a new app pool because we had to kill the old one, so it's got to start up again. Hello, St. Pete. All right. Wow, I'm going to have to speed up. Okay, so that's that. Oh, cancel. Just leave it up. All right. So the next step is get stash work this time. All right. Get checkout. Oh, get branch. All right. So the next one is dev watch, which also has unit testing built in. So we'll get to see that. Get checkout ASP.NET dev watch. All right, so because we're of what time it is, I'm going to speed up a little bit. So if I need to focus on anything, let me know. I believe in this one that there is no change to the Docker file. And I don't think we'll be making any more changes to the Docker file, but we'll keep coming back to check because I may have forgotten that I changed something. There is, however, an explosion of batch files that I've created, and I also created PowerShell files, but they're exactly the same, really. So the new thing that's here is this Docker Compose. So Docker Compose is a way where you can configure all those things that we were configuring, but you can configure them in a file so that when you actually go to run it, you don't have to specify this mile-long Docker command. What this particular Docker Compose is saying is that we're going to call our service or our container using docker-web. We're going to use the image, which is .NET development, which is what we're going to call the image that we create from our Docker file. Then we're going to set some environment variables on the Linux machine, which is going to be, we're going to set the environment to develop, and then we're going to set, so specifically for the file watcher in Linux, you have to use a polling file watcher. Whereas if you were running local, you don't have to poll, it can actually watch the files directly. But we have to set it as a polling watcher or it doesn't work remotely. Then we're going to set up some volumes. So earlier when we were setting up volumes, really we just set up the first one, the source to app. Now we are setting up what are virtual volumes. So they are stored on your machine somewhere, but nowhere that you have direct access to. And the reason we're setting those up is because we don't want those files locally. So we just say, Docker create an extra volume to hold these files, because when I run, I don't actually want the bin directory to be stuck on my machine because I'm not actually running locally. No reason to have bin or lib or obj. Again, we're going to set TTY to true. We want to get that colorized feedback. We're going to map our port 3000 to 80. We're setting our working directory, in this case, to the using docker.web folder. Our entry point is going to be bash shell with a -c. I don't know what that means. Then we're going to run as a command. So the command gets passed in as an option to the entry point whenever you set up commands. You can set up multiple commands, but they're just going to get stuck onto the end of your entry point, whatever that is. So the first command we're going to run is .NET restore. Then we're going to run bower install with the allow root option. And then we're going to run .NET watch run. In order to run the .NET watch commands, you have to add a reference to, where is it? Tools, Razor, Core, there it is. Microsoft.NET Watcher Tools. The current version, as of when I put all this together, was 1.1.0 Preview 4 Final. They may have a new version relatively soon, so you'll have to keep an eye on that if you decide to use these files for anything. That's all you have to add to the project JSON. The rest of using Docker Web is the same as what it was. And then we have the Docker Compose for test. It's almost exactly the same. The only difference is that we have to set our root volume. We have to set it as the actual root, because when you run .NET restore, it has to be able to restore your source code so that it can import it into the test code, which is kind of annoying. It can't go find your source code. Everything else is basically the same, except for we have to change our directory to the test directory before we run watch test. I have a couple commands. I have dev and I have test, and then I have dev test, which just starts both of them. Dev, the first part, is very, very similar to what we've seen before, where we're going to create a .NET development build, and we're going to remove it when we're done with it. And then Docker Compose is the new part. So generally, you just say Docker Compose up, and it will find your Docker file, and it will launch your application. But because we have several Compose files, we have to tell it which one to use. That's what the -f option is for. So for development, we're just going to use dockercompose.dev.yml. It's a YAML file, which just means that every tab, like if it were XML, every tab is a nested element. Let's see. Test is almost exactly the same as before, except for our dev is what's actually going to build the image. Test is just going to use the image, so we don't have to rebuild it. And then we have dev test, which, like I said, just runs both of them. So if we come over here and we say /dev, is it the other slash? Does it care? I don't like PowerShell. Bat. All right, so we get 2 windows. Oh, nothing happened. Okay, whatever. All right, let me sneak peek. All right, yep, that's working. Okay, what about this? Yep, we're good. Okay, so here's what the output looks like, and if you see it, it's got, oh, you can't see that? All right, well, I'll tell you, in turquoise, it has using Docker -test_1. So this is the first instance of that particular Docker composed machine running or service. And then down there it has the same thing except for web_1. So first instance of that particular piece actually running. If we ran another one, I believe it creates a 2 and then a 3 and then a 4. On the web side, you can see that we are now actually running our virtual machine on port 80, hosting up the web application. And then over on the test side, we have 1 test, 1 passed, none failed. If I go close, if I go over here and I refresh, this is without edits, so we should see application uses, yeah, right there. But then, if I come back to code and I pop open the source, go to the views, go to the index, and change this back to hello St. Pete, and I save. Did it save? Should have saved. Now when I refresh, now it automatically has the new information. If that one is probably because we have the volume mounted, but if I go into my actual code, and we're going to do the most important code I will write today. Oop, not that. That's very, very important. And I save. Then we can see my tests are running. And this code should have recompiled. We still have all our tests pass. I can't see that the other code recompiled, but in all my tests, I normally have this stuff in another monitor, and it does recompile. I'm not seeing it here, but it may not have recompiled because that had absolutely no effect on anything. But it does work, I promise. Multiple tests around 2 a.m. in the morning. Okay, so all of the magic to do that went into just these 2 composed files that you see, and then the commands that I'm running in the batch files, which are very, very simple. And then of course adding the watch tools to both the test project and the web project. That's pretty much it for development. So for a development cycle, you write a test, it recompiles, it runs the test fails, you go and you update your source code so that the test passes. It should recompile the website, recompile the test, rerun the tests, restart the website, and then all you have to do is go refresh your browser and do your integration test to make sure that everything worked out good. As long as you're doing a quick feedback cycle and not writing hundreds of lines of code and then expecting that everything was hunky-dory, then this process works really good. If you write 300 lines of code and then realize that you had an error, I'm sorry. You'd really want a debugger at that point, and I haven't figured out how to do that simply yet. I don't know if you guys think this is simple or not, but this is the simplest that I could make Docker. All of the examples that I found are really complicated. Okay, so now onto the part that I don't feel is covered by enough of the pre-built options, deployment. how in the world, we've done development, but the whole selling point for Docker is that you can develop in an environment, and when you deploy, you're deploying the same environment. And most of the solutions, I believe the Visual Studio 2017 solution does cover that aspect, but most of the solutions, they don't care. They don't pay attention to it at all, which is really sad, because then what's DevOps to do? Like they gotta figure out how to deploy something, and you're still stuck saying, well, it works on my machine, which it's not a good situation to be in. Hopefully I didn't change anything, did I? I did change stuff. Git stash. All right, git branch. All right, while I'm doing this, does anybody have questions about the last part of development?
Is there a way to just remotely connect to the Docker environment through Visual Studio to debug or anything?
So there's a remote, so that's the complicated part. You have to install the remote debug tools for Linux, but you can only do that as a run command into the Docker container. So you do that as a run command, and the run command involves downloading the remote debugger tools, checking them against a hash to make sure that they haven't been altered, installing them in the proper location, exposing the debugging port, and then you have to have special configuration in your project so that Visual Studio can pick up on that and use it. And 9 out of 10 times it doesn't work.
And you don't want that going to production.
Right.
in the Docker image.
Yeah. Which, for the deployment part, we're actually going to use a different image. So that may not be a problem. But the way I've got it set up, which we'll see here in just a second, a diligent developer would be able to test that it's going to work in production. And that was really my goal. Not that we're running the exact same image that we're running during dev and production. Because they put a lot of stuff in the build image that you don't really want in production. Let's see. ASP.NET. All right, for time constraints, I'm going to skip the build because the deploy also has the stuff for build. Here I was worried that I wouldn't be able to talk long enough. Everybody's still awake, right?
Oh, yeah.
Except for that guy in the back. It's all right, though. Okay, so not a whole lot seems to have changed, but what we added, I'm pretty sure that the Docker just keeps jumping over there to the end. The Docker file hasn't changed one lick. There's nothing different about the Docker file. Once we get that first part going, everything's hunky-dory. We have added an extra Docker file, and this is where the deployed image comes in. There's this Docker file here, which is only slightly different. We're actually going to copy from our published directory, which is going to be a local directory when we run publish, to the app directory, set the working directory to app, and then in production, instead of .NET Run, you .NET the DLL that you actually want to run, which I feel is kind of odd, but that's what they do. And you can see at the top here, for this image, we're using Microsoft/ASP.NET Core 110. So it doesn't say anything about Project JSON, and we've got a different hash that we have to have. This image is unfortunately still around 1.5 gigs. And it's just because the base image that these Docker images are built from is large, and they install Bower for you, like out of the box. They also install Node. I had to actually submit a pull request to update to the LTS version of Node because they were 2 whole versions behind. They were on 4.9.1, and the LTS currently it was, well, when I submitted, was 6.9.4. They were like way behind, but they're up to date now. I'm gonna try to stay on top of that because they're not. Okay, so the things that we have added, we still have the same batch files that we had before. We have dev test, dev, and test, but we've added build.bat, which is the one that the repository or the branch that I really? I guess that's the start. Okay. All we're doing is we're using Docker Compose, except we're using the build YAML file, which is the same as the other ones, It still uses .NET development. It depends on using Docker test report. So here is where the depends on is I'm saying that I also require this other service. So somewhere else I'm defining, I think it's lower in this file, but I'm defining that I want to run tests and generate a report. I don't know how many of you are doing it, but at our work we generate an XML file as the test report, and then we use Jenkins as our continuous integration, and it can import that XML file so that we get a test results as part of the build. And if the test results don't pass, Hudsy fails us. And everything, we get rejected, and then we go cry, and then we fix it. We're setting our environment to production instead of development. We're not polling because we're only building this once and then we're stopping. We still set up the virtual directories or the virtual volumes for lib, node modules, bin, and obj because we really don't want those local. We don't need them. They may or may not get generated. They changed something at some point, and so my virtual volumes stopped working quite right. I can't remember if I fixed it or not. We'll find out. TTY is still true because we want to see the output. And without TTY true, you get a black and white output instead of a colorized output, which is a lot harder to read. Working directory, our command this time, because we're trying to publish locally, is .NET restore. Then we browse to the directory of the web project, and then we run publish using configuration release, and we output to /app/published, which is that command is the same one you'd have to run if you were DevOps and you were trying to just generate the actual files to deploy. Okay, yes, here is the Docker test report, which is going to run our tests. And we have some configuration down here. We are using XUnit for these tests, or I am. And XUnit allows you to specify that you want an XML output and what folder to put that output in, or what file to put that output in. So I've just specified it there. If you're using the updated MS test that you can use with Core, I'm not sure that it has the XML output, so you might have to find another solution for getting the output for your tests. And then we simply just run it. So, all right, that's going to have to do restores and stuff. Any questions while we're waiting? Hello? That's all right. Do they have any questions? Oh. I'll bet I could get him to go to sleep. All right, so this takes a little bit. You can see, I don't know if you saw it just jump, but it just created the published, or they were probably, I think the reports. Yeah, it created the reports directory right up here. And while we're waiting for the publish to finish, this is the XML output that we're using in our continuous integration. I thought the whole room was coming down. All right, again, total one test. Highly tested application. We have one passed, no failed, no skipped. And now down at the bottom, compilation succeeded, so our actual publish should have worked. And now here we have our published files, which is a load of stuff. You guys ever looked at this? It's crazy. Here's our CSS, images, JavaScript, yada, yada, yada. If you are doing like a SPA, then you'll need to have your pre and post publish scripts in your project JSON or Xproj or whatever it is properly set up to build all of the node stuff that you need. All right, and then that's done. So then the next thing that we need to do is deploy. I'm deploying directly to Docker Hub. I created my own repository there for this application. So I have configured that here. So I'm going to push my Docker image to Clayton Hunt / using -docker : latest. And it's going to build using the Docker file that's out here in the open, the one that's designed for not using the ASP.NET Core build base image. If you are going to push to a Docker registry, whether it's Docker Hub, Azure Docker Registry, or Azure Container Registry, or Artifactory, I'm sure there's others, but those are the 3 I know of. You will need to log into that registry so that you can run those push commands locally. Generally, if you do have a DevOps personnel, you will not be the one running this command. You'll run build, and then you would not do the Docker push. You'd comment that out or delete it altogether. They would do the push, and all you would do is run the build for this. Up here I've got Clayton Hunt / using -docker : latest. And then you just run that image locally. Yes?
Would you commit that image to source control?
Yes. Well, no, not the image. The registry in this case is sort of your source control. Yeah. And again, if you have a DevOps solution, you probably wouldn't always push the latest. You would push, so our DevOps likes to use the build number, so 1, 2, 3. And then when they want to deploy 1, 2, 3, they would also tag 1, 2, 3 with latest. And then what I'm going to show you in a second in Azure doesn't quite work yet. I'm hoping they work on it. It is a preview, but should automatically update because you've retagged latest, and it will automatically deploy right after it downloads the appropriate files.
Surely when DevOps pushes this out, are they having to download that image every time, or can they pull from the cache?
Well, so as long as I don't change the SHA hash in my builds, they would already have the majority of the files. So the only thing that they would have to download or redo every time is the stuff that ends up in the published directory. So all the DLLs from your packages that your application is referencing. They would not have to re-download the 1.45 gigabyte container image.
That would be time consuming.
Yes, yeah. When you update the hash, they would. But again, if they updated the base image and so you get a new hash, if they don't update the operating system, if they leave Debian alone, they still don't have to download that 1.45 gigs because that 1.45 gigs is Debian. They would only download the 30 or 40 megs that consists of whatever changes have happened. So maybe a new version of Node. Maybe they got to download that, or whatever the other steps are that may have changed. They don't have to, as long as the hash for that step doesn't change, Docker will not make you re-download it. In fact, like if I go here, and I copy this, and I say Docker pull, and then I'm going to pull that image, right? Which I already have. So what it does is it goes and looks for it, and it says status is up to date. But if I dropped the hash, I don't know how long this is going to take. All right, if I drop the hash and run it, they may have updated it since this hash. So what'll happen is, so see how this first one, 504 starts with, this already exists. That's the 1.45 gigs. So the only part that I have to download is this, I don't know, 100 megs worth of stuff, and then it updates.
Nice.
So what are those data volumes?
Yeah, so remember I was talking about run and how it treats that as a layer? So the base operating system is one layer. If you do a copy, so we copy our local file system to the image file system, that's another layer. So if we're not copying new files, then it won't rerun that. It'll do a hash check, and if the hash is the same, it just leaves it alone. Then you have any run commands that you're going to run. If they are static run commands, like downloading a file, as long as the file that you're downloading hasn't changed, it'll hash it and it'll say, nope, we've already got that, we're good. If you do a .NET restore like I was doing earlier, it can't hash that because that's a dynamic thing, so it has to run that. But every step like that you do is a layer, and as long as the layer hasn't changed, Docker doesn't have to re-download it. Doesn't have to recompute or anything. It's actually really awesome because otherwise I'd be eating up tons of bandwidth. All right, okay, back to deploy. Okay, so I'm going to tag this with 1, 2, 3 so that we can see a difference. If I go to my Docker hub, oh, see, I forgot the part I was going to tell you, which is extremely important because nothing will work without it. All right, sign in. Oh, don't look at my password.
The display went out conveniently just for you.
Yes.
And we're back.
Uh-oh. Let me try that again.
What's your password?
Let's think about the dots.
I don't know. Hey, I remembered it. It's invalid password. Okay. All right. So if we go over here and we look at, we go to my Docker image that I've pushed up to the registry, and tags. All right. So tags. So I've got latest and I've got 1.0. I do not have 1, 2, 3. So if I say deploy, so it's going to build that image, and see, layer already exists. So the only part it has to update is 18.5 megs because I've already uploaded all the rest of the stuff before. Pushed. So now I go to Docker Hub and I refresh, and we should see 1, 2, 3 eventually. There we go. No, we don't. Come on. I don't know how long it takes for it to show up. Do I need to pull up DevTools so that it doesn't cache? That's it, it hates me.
Maybe it's processing on the server.
There we go. I'm sure it takes a little bit of time. I've never tried to get immediate results from it, so. It will show up there eventually. So anyway, once it shows up, oh, latest was a minute ago. Hold on.
Oh, you didn't save your file.
That'll do it. Let's try that again. Watch, it's gonna be like everything's already up there. So it didn't have to rebuild anything because it already knew. Now we can try it, and I can stop looking like an idiot. There we go. Okay, fantastic. That's what should have happened the first time. Pretend like the last 3 minutes didn't exist. All right, so now that we have that, I should have changed something. I didn't change anything, so you guys won't be able to see. Okay, anyway, I have created, and I'll show you how in just a second, but I have created an Azure, not com, an Azure website from my Docker container, which is this one. I didn't change anything, so we're not going to see magic, but do I still have it open or did I close it? I think I closed it. All right, we'll just go into it. Yes. All right, so there is a new thing still in preview. I'm hoping they correct some changes, like I said earlier, or correct some issues. But there is a new app service called Web App for Linux. And from Web App for Linux, I've created using Docker. So when you go to add a new one, you get almost exactly what's right here. You just have to fill in the name, select a resource, and then move on. Has anybody not used Azure for anything ever? Everybody has. All right, so everybody's created something. Okay, so the wonderful thing about Web App for Linux is that I can come down here, which you, oh, that's horrible. Okay, it says Docker container for anybody who can't see it. And all I have to do is say, wow, hold on, can I scroll? Of course not, because, all right. The blue part at the top, right here, says Docker Hub. There's also built-in. So from built-in, I can select some of the standard images. I can select a node image. I can select PHP. I can select .NET Core 1.0. So they don't even have 1.1 yet. I can also select Docker Hub, which is, excuse me, the one that I'm using. and I can say 1, 2, 3, and save. And then it's saving the settings. The settings have been successfully saved.
So really, by choosing a built-in image, are you just saving the time to download it? Like it already has that image?
Yeah, they already have it downloaded. However, what are you going to do with it? It's a built-in image that, I mean, like, you could remote into it, I suppose, but your app is not in that built-in image, so I don't know why they even bothered. I want to deploy Node. I can't do anything with it after I've deployed it, but I want to deploy Node.
Can you deploy from a blob storage or something as well?
The options for Docker deployment are built-in, Docker Hub, which is what I'm using, and private registry. So private registry is where you could select, sorry, I can't make it scroll. I don't have a mouse. Private registry, you can select Azure Container Services or like Artifactory. Has anybody heard of Artifactory? Okay. And all you have to do is provide the URL, login information, and you're hot to trot. You're ready to go. The one thing that I think that they should fix is currently, in order to force any kind of update, I actually have to come in and again, you guys can't see that at all. I have to come in and tell it to update to a new tag. I can't just leave the tag at latest and then update what latest means and it figure it out. I'm hoping that they fix that so that they get some kind of auto recognition that the tag has changed. Just leave that like that. They do have deployment options, but unfortunately the deployment options are local Git repository and GitHub, which isn't going to help if we're deploying a Docker container. That's it for web app for Linux, though. It's really, really, really simple. I tried Kubernetes. I tried, there's Docker Cloud. I tried container services for Azure. I tried all kinds of junk. It's impossible to configure. I don't know how whoever's configuring it configures it. It's crazy. This, I just select the hub and I'm ready to go.
No, you said you couldn't deploy from a local repository because it's a Docker image.
I could technically, well, actually I don't even know what I could. The Docker images are stored in your local registry, or they're stored in a remote registry. It's not, I don't have physical access to I can't say, here is my Docker image, which I never showed that. For anyone who hasn't used Docker at all, you can look at running applications and you can look at images. For images, all you do is you type Docker images, you hit enter, you get a list. I will open this up in one. Oh, I'm still running. Stopping. I'm impatient. Okay. So let's do this again on a little wider screen. Nope. Okay, so here's a list of the Docker images. So I've got my Docker images, Clayton Hunt using Docker. I've got .NET-development, which is another one of my images. I've got none. So if you guys can see the none up there in angle brackets, that is a leftover artifact from installing or pulling down an existing Docker image. So when I pulled down Microsoft/ASP.NET Core, it may have left that none on the system. And even there is an option that you can pass to tell it to clean up all of those artifacts, but it still leaves them. So the best thing you can do is just watch your images and occasionally delete the ones that you don't need, anything named none. To remove an image, it's docker rmi, and then you can't call the image by its name. You have to call the image by its image ID. The nice thing is you don't have to specify the whole image ID. So that none is 2dbf189d2e75, but I can simply say 2db, and then it deletes it. You can also, if you want to delete multiple, you just say docker rmi space first 3 letters space first 3 letters space first 3 letters, and it will attempt to remove all of them. sometimes you have conflicts, there's dependencies. If you try to remove one that another one depends on, it'll just skip it and tell you it can't remove that one. And then after it removes the one that's depending on it, then you can go and remove it again.
So the top two have the same image ID. Is that because there's nothing different between them?
Yes, they are the same thing. The only difference is they have a different tag. So the first one has the tag 123, and the second one has the tag latest. So it's really just one image that I've tagged with multiple tags. You could tag it with 100 tags if you wanted to.
But so if you removed that ID, it would take both of those away.
Yes, and we can do that. Not there. I don't know what I'm doing. Okay. RMI B05. So this one is referenced in multiple repositories, but I can say I don't care, remove it anyway, and then Docker images, and now it's gone altogether. So those are the images. Those are think of it like the hard drive from an operating system. It's not the running application, it's just the files. To see the actual running applications, we have to do Docker PS. So if you're familiar with Linux, this is processes. So right now, and this is why we got the error earlier, I actually am running a process named FA16E2C yada 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 from the image .NET development, which was depended on because of the it had a dependency on the using Docker, I believe. To remove these, it's just RM. So RMI for remove image, or RM for just to remove a process. But I can't remove it straight away, I have to stop it first. Again, we can't remove it based on what we would like to remove it on. We have to remove it based on the container ID. I could remove it, so it says, hard to see right here. It says using Docker underscore using dash Docker dash web underscore one. I could technically remove it with that, but I think I have to specify the whole thing. Or I can remove it with the ID, and then I only have to specify the first 3 letters. So Docker stop, FA16 for good, oh no, see? Shouldn't have added the 6, okay. And then it's go, so we have to stop it. We can't kill, or we can't remove a running process. We have to actually stop the process first. Takes a little while. There we go. And now I can remove it. So FA16, and now that one's gone. So Docker PS. Now, if you know that you have images but you can't see them, you can do Docker PS-A, which will show you all your images. Everything for Docker processes, or containers, or Docker images is really, 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 really junky. Like it will collect hundreds of them, and the information for them is so long that even when I've got my DOS prompt, my command prompt spread out across the whole screen, it doesn't fit. It's had to wrap, which makes it hard to read. So that's why I do the --rm when I'm running my my containers. You still end up with stuff though. So you have to be really diligent about removing your stuff. If you don't give it a name, it will give itself a name. Like grave go lick. Or loving Perlman. It'll just make up anything. So it's good to name your images so that you know what it is that you want to remove, should you want to remove it. All right, I think that's pretty much it. And we did not go back to the slides hardly at all, did we? All right. Yeah, okay. So we talked about continuous development and continuous tests. We talked about the Docker Compose. We talked about publishing and test output. And we talked about deploying the application. And we're back to my face. So are there any questions that are still out there that I need to answer? Yes?
What if you want to run something that's Windows-based, like SQL Server or IIS?
So to do Windows, you have to run it using Hyper-V. So you have to have Hyper-V turned on. which is kind of the default right now. It'll prompt you to do that anyway when you install Docker. But you have to have Hyper-V, and then there is a Windows microserver, I think is what it's called. But you can actually run a Windows server that's actually only like 500 or 600 megs. And then you can run anything that you could run on Windows Server there. It's bare bones though, so if you need IIS, you'd have to run the command to install IIS. If you need whatever, you have to run the command to install that feature for Windows Server. And those are, the way that I find all these things is I just go to Docker Hub and misspell Microsoft. And then when you search for Microsoft, is it searching? Okay, so there's Microsoft.NET if you want to run a .NET application that's not web. Azure CLI if you want to do something with Azure. ASP.NET for running a web application that's not .NET Core. ASP.NET Core for running a core web app. ASP.NET Core Build for building a core app. OMS, I'm not sure what that is. CNTK, .NET Nightly if you want to be on the bleeding edge. .NET Samples, PowerShell Nightly. I mean, it's just on and on and on. Mono. And then these other ones down here that you can see now, well, that you can't really see, they end in Microsoft, and it's because somebody took one of the Microsoft images and they've made their own custom versions. So you can never know what's going on there. Here is Nano Server. That's what it's called. Microsoft Nano Server if you wanted to base an application off of Windows Server 2016 Nano Server. Does it have a size? I don't see a size. Oh, there we go. 333 megs compressed for an actual instance of Windows Server, which is that's not bad. I mean,
Any other fun containers you came across while putting this together? Or?
I mean, you can run Minecraft. I mean, if it is not a graphical user interface, if it's something that you can do from the command line, it's almost guaranteed that somebody has created a container. If I remember correctly, I think Docker's been around, started in like 2010. It's just now getting to Windows people, but it's based off of a feature of the Linux kernel, and they've just been building on it since 2010. It's still a bunch of Linux witchcraft, unfortunately. Those Linux people are not the best at friendly user interfaces. They're quite terrible at it. But if you like reading docs and taking migraine medication, then you can get around.
So what if you wanted a custom implementation of IIS? Maybe you don't. I mean, I guess what version of IIS is it using? Is it Express, full version? What's it use?
Whatever you want. So the .NET Core stuff in the ASP.NET Core container or image that already exists is not using IIS. It's running in Linux, so it's using Kestrel.
Interesting. Okay.
If you were going to run against Nano Server, then my understanding, I could be wrong because I haven't used Nano Server, but my understanding is that it's bare bones. It's like damn small Linux or something like that. It's just the operating system, and it's not the GUI. It's just the command prompt of Windows Server. But if you can write a PowerShell script to install the feature that you need, then you can execute that PowerShell script in Nano Server and install whatever you need.
Beautiful. Okay.
And then you have complete control over which version of IIS or what IIS settings that you want, custom configure your app pull and all that stuff. Just can't do it from a click-based setup.
Fair enough.
Anybody else?
Does the Docker has like a desktop version? So can we have Docker?
There's what's it called? It's called Kitematic. Yeah, you can't see that at all. Okay. Can you read that at all? So Kitematic is a graphical user interface for Docker, and it also allows you to browse. I'm not going to download it, but it allows you to browse the Docker containers that are the Docker images that are on Docker Hub kind of graphically, like they have icons and stuff. And then you can add them to your pool of existing containers or images, and then you can launch a container from an image just by double clicking, and it'll run. But in my experience, like almost every graphical user interface designed to work with a system that was designed in Linux, there's so many issues with actually using it that I don't think that it's worth it. It's if the system was designed to be used from a command prompt, sometimes it's just easier to use the command prompt. But you can use Kitematic if you want. And for anybody curious, I just saw it. You can't see it, but what I'm hovered on right now says switch to Windows containers. So right now I'm not using Windows containers. I'm using standard Linux. So there's a I believe it's Ubuntu is the core image base that Docker is using. So I'm using a Ubuntu Linux distribution image on my machine that's running as a virtual machine. But I can say switch to Windows containers, and then I'll be using Hyper-V, and I'll be using probably Windows Nano Server, or it could even be a full installation of Windows Server 2016. But then I can do any of the Windows stuff that I might want to do. And one of the nice things with Windows containers is you get you can have special interactions with your machine and the Windows-based Docker container, allowing you to semi-bypass some of the security restraints from using a Linux Docker container. All right, is that good enough? Okay, anybody else?
I have one
Oh,
more
yep.
question. So can this, I haven't used the Docker before, so can developers can actually work on Docker? It's like they write their code and then push to the source control, and then from there, Docker is mainly like pulling the source and then building it and pushing it to the servers.
Sort of.
Actually, devs
Yeah.
can work on Docker VMs. How?
Yeah, that's what the whole process that I configured was. Every bit of my development process was inside of a Docker container. So everything I did today was 100% in the Docker container. If I tried to run the application that I had, if I tried to run that on this machine, it wouldn't be able to, because I don't have .NET Core 1.1 installed. I only have .NET Core 1.0. So I can't even create the app that I was working with and running on my machine. So the entire process was inside Docker container. I know before, when I submit my pull request in TFS or Git for TFS, when I submit my pull request, I've already done everything locally. I know that when DevOps deploys to test, that it's going to run, and it's going to run without any errors that I know of.
So what you are saying is in an enterprise level, everybody will be working on the Docker machines.
Yeah, potentially. There's a whole lot of decisions that go into making that jump, but it's possible, yeah. And then all you would do is you'd follow your normal source control operations, but you would be running Docker local. So you run Docker local to develop, and then you commit to Git or check into TFS, whatever your process is. And then before you create a pull request or ask for a code review, you would just run what would be deployed version locally. And since it's running in a container, and a container that you specify with that hash, it's going to be the exact same code that's going to run when they deploy it to test or to prod. So you know exactly what they're going to get. There's no questions of like, it works on my machine becomes it works on the Docker machine. And so if they can't get it to work, it's their fault because they're not doing it right. Because you got it to work on Docker, and that should be enough. That's the one thing that Docker removes, is it removes the chance that when it deploys that everything's going to go terrible. Everything just gets leveled out, and you know that it's going to work 100%. So you would run it locally. You'd create your pull request, or you'd create a code review request. Your code gets reviewed. It gets merged into the appropriate branch, whether TFS mainline branch or Git master or whatever. Then the DevOps continuous integration, continuous deployment process kicks off. They kick off from source control. They pull down your source control. They run a script similar to what I was using for deploy. which generates a Docker container and then stores it in, let's say, Artifactory if they're using Artifactory. Then they can take that image and they can run it in Kubernetes, or they can run it in Docker Cloud, or they can run it in AWS Container Services or Azure Container Services or web app for Linux. The possibilities are nearly endless, and I'm sure during this talk that 5 more solutions were created.
What, so kind of building on that, what types of things should be or would be containerized, and what would you avoid? Like, you know, is this a one solution for every problem, or, you know,
You
where do
may
where do
or
you draw that line?
yeah, so you may or may not containerize your web app, like I did for this example. But you almost certainly would container like a microservice, and you would containerize your SQL server or document database or whatever kind of database you're using. You could containerize those, but you have to have some kind of network addressable storage in order to be able to access it and not lose it when the container crashes or dies or whatever. But any process that you want to have basically infinite scalability and global availability, Docker's a great solution. Just about any web service that you want, and you could do it with the web app. I don't know if in the end if you would, but you totally could. But microservices are probably the prime candidate. Yes.
There's another aspect to Docker as well. If someone hacks your website that faces your web page, and you happen to find the leak, you just redeploy the Docker image and you're done. Like,
yes.
Your entire website's patched.
Or
and so it's a great buffer against hacking attempts.
yeah, you can essentially have immutable parts of your application. They can do whatever they want to, and you just go, oh, nope, redeploy, no problem. Only your data would be, especially for a web app or microservices, your data is the only thing that you don't want them to hack. The rest of it you don't care about. Take it down, bring it back up. No harm, no foul.
So how about applications that are like distributed across in your conventional way across multiple servers? How would that play a role using Docker?
Depending on what kind of service you're running. If you're running a microservice, then it's no issue. You can run the same Docker container image in, like say in Azure. I could create a resource group for Europe. I create a resource group for Eastern America, Western America, and China. And then I can just say, yeah, all of those deploy a container for this application. And you can even, using the Docker Compose files or some of the configuration that you can do when you run the Docker image, because the image that gets created, you can always modify. I can add, at last minute, DevOps could add language equals to the environment variables. And then I can say, so for the Chinese region, I'm going to add language equals Chinese or Cantonese. For the Western American region, I'm gonna Chinese equals Soho, and then for the Eastern China, language equals Harvard. I don't know. And then when you deploy, just automatically those different regions, when they pull down the code, they get the language translations or any other thing that you might want to change. So you can distribute, and then you can also, because it's Azure, you can set your scaling properties. There's, do we still have it open? Yeah. So scale up. I know. Scale up, I can just click on one of these and say go. And all it does is it just creates more containers. It's very resilient to, like he said, if it gets hacked or something happens and it crashes, just fire up a new container, no problem. It will without question just trash the existing container and not care and just fire up a new one, because the app itself is immutable. It doesn't matter. The only thing that matters is your data source. Anybody else? Everybody's still awake. It's amazing.
These are medals or giveaways. All right, so thank you, Clayton.